In this video, I'm going to explain why the Lightning Network cannot actually scale Bitcoin to mass adoption, as the Bitcoin community is now starting to realize, and why, given the current scaling trajectory, namely Lightning and Liquid, 99.9% of people will never be able to own or use real Bitcoin, but instead would be forced to use Bitcoin IOUs issued by custodial services, aka banks, which of course means that fractional reserve becomes possible and inevitable because these IOUs can sidestep the 21 million hard cap, and we're back to the same system we were trying to escape from. So Lightning is state channel, or more specifically payment channel technology, and this is a general blockchain scaling technique that has been around for about 10 years now, and it's not exclusive or specific only to the Bitcoin ecosystem. In fact, Ethereum had its own version of Lightning, more or less, called the Raiden network, which has now been supplanted by rollups. But this is a general blockchain scaling technique, and the issues that I'm going to highlight for Lightning are not just bugs that can be worked out over time, they're just inherent limitations to this technology itself. First, let's recall why we're trying to scale with layers to begin with. So we have our Bitcoin layer 1, which is our global decentralized ledger, and this system is run on many thousands of computers spread around the world, and we can't run the system too fast, because if we do, these weaker, more consumer grade kind of entry level computers will not be able to keep up. They'll fall off the system, and what's left will be a bunch of high-end servers run by a few number of people, and the whole system becomes centralized and it defeats the whole purpose. So we can't run the system too quickly. And currently, Bitcoin is running at something like 5 to 7 transactions per second, which is orders of magnitude too slow, too little for global decentralized digital gold. Never mind peer-to-peer electronic cash. For that, you need hundreds of thousands, millions of transactions per second, right? Visa alone, for reference, does 2,000, and in peak times, like 20,000. And that's just Visa, right? So for a global system to serve all of the financial needs of the world, we're going to need hundreds of thousands, millions of transactions per second. And we just can't achieve that on a layer 1 because we would have to centralize the system to do that. So the solution is to scale on layers, which is where Lightning comes in. So with this diagram, I'm trying to give a visual representation of how Lightning works in relation to Bitcoin. So we have our Bitcoin layer 1 down here, and each of these little cells is meant to be a wallet. And these wallets can transact with each other, no problem, on the layer 1. But of course, they're limited to that 5 to 7 transactions per second, 10-minute block times, and the fees associated with that. So what you can do is you can migrate, so to speak, some of your Bitcoin up to the layer 2, up to Lightning. Now, this works a little bit differently, though, compared to Ethereum L2s, because with Optimism or Arbitrum or Base, you can migrate ETH from the layer 1, from Ethereum, to that L2, and then just transact freely in that world. It's like you enter the Base universe, and you can send ETH or tokens to any other wallet, any other account. You can interact with the apps. You just do whatever you want, right? With Lightning, it's a little bit different because this is state channel or payment channel technology. You don't just enter Lightning, the Lightning network, and then you can transact freely. Instead, you have to open a channel specifically between yourself and some other entity in the Lightning network, and then you can start transacting. And I'll explain how that works in a second too. Now, the good thing about these channels is that once they're open, you can transact between yourself and your partner basically for free and as quickly as your internet connection will allow. Because the transacting that you're doing is happening entirely off the record, so to speak, as far as the Bitcoin L1 is concerned. So you're not paying any fees to Bitcoin. Bitcoin is not throttling your activity at all, except in that you have to interact with the Bitcoin layer 1 to open and close the channel, which I'll talk much more about later. But apart from that, the actual transacting between yourself and your partner is very cheap and very fast. To give an example of how this flow works, suppose you and your friend want to transact with each other on the Lightning Network. What you'll do is you'll each create a transaction on the Bitcoin L1, sending some Bitcoin into the channel you're creating, basically. So each party will deposit some initial amount of Bitcoin. So let's say you deposit 0.2 BTC and they deposit 0.3. Now the total overall channel capacity will be the sum of those, 0.5 BTC. But the way it actually works is that the most Bitcoin you can of course send to your partner will be constrained by the amount that you deposited on your end, right? So if you put 0.2 into it, the most that can flow from your side of the channel to their side of the channel is 0.2. And of course, it's the same in the other direction. The most that can flow from them to you is zero point 0.3 BTC. Now, as you're transacting, you can transact very cheaply and very quickly. And so you might send money back and forth for a long time, or if you're in a situation where it's a little more one-sided and the money flows mostly in one direction, like maybe the channel is between you and some kind of store or shop, then what'll happen is eventually you exhaust your end of the channel. That 0.2 BTC flows, it ends up being owned by your partner. Then what you have to do is settle the channel back down to the L1. So with Lightning, you can't just kind of add a little more BTC to the channel. The way you do that is you have to settle the channel, close the channel, and then open a new one. So what happens when you settle is that the channel is closed and the outstanding balances are basically settled to the L1. So in this case, your partner will have gained that 0.2 BTC that flowed toward them. And when the channel closes, that'll all settle down to their account on the Bitcoin L1. An obvious problem here is we don't want to open a channel between ourselves and every single entity that we interact with, because that would be a lot of channels. Fortunately, we don't have to do that though, because with Lightning, we can route payment from one or through channels to other entities in the network. So for example, if you're A here and you want to transact with B, you can actually do that because you have a channel open to this guy and he connects to this guy and then this guy connects to B. So the payment can route its way along this path from A to B. Now, one of the caveats here though is the channel capacity thing, because obviously you need to have enough Bitcoin on your side of your initial channel to make its way to B, right? If you're trying to send B 0.1 BTC and this channel that you already have is already exhausted and you have like 0 BTC on your side, obviously you can't do it, right? But suppose you do have enough, you have 0.1 on your side of this channel, right? And you want to send that 0.1 to B. Well, it actually might not work because all of the intermediate channels need to also have sufficient capacity. So you have your 0.1 here, it flows to this node. Now this guy needs to have at least 0.1 on his side of this channel with this guy, right? So there needs to be 0.1 here to flow to here. And then there needs to be 0.1 at least also flowing from here to your final destination to B, right? So this routing is great. You can basically send money to any entity in the network, but it's limited by the channel capacity at every single hop. So there needs to be sufficient capacity through that entire path. And if one of these links in the chain, so to speak, doesn't have enough, then you have to find a different path. Maybe you go this way and then back here and then up again. So it becomes this problem of finding a route that actually has sufficient capacity. This routing complexity and channel liquidity stuff can be alleviated somewhat by the existence of hubs. And these are just entities in the network that many other entities connect to, and they serve as hubs, right? So rather than connecting to your buddy who connects to some business and then that business connects to someone else and on and on and on, and then routing your payments through that web, instead what most users will do is they'll connect to a hub, and then routing payments becomes pretty simple, right? If you're this person here and you want to send Bitcoin to this person or this person or this person or this business or whatever, then it's very easy. The payment just goes to the hub and then out to the recipient, and then that's it. So routing becomes much simpler. And also the liquidity thing becomes simpler too, because in this scenario, rather than having, 20 channels open to different businesses and people and so on, where each of those channels is going to be a relatively small amount of money, it's kind of like you're splitting your monthly budget across the 20 businesses you spend money at, right? In that universe, routing becomes hard because most channels have low liquidity, right? But in this realm where we have hubs, most channels, like most people are opening one large capacity channel or a couple, then the average channel has higher capacity. So if we do need to route payment outside of our little hub to another hub or whatever, it's going to be generally easier because most channels just have more capacity. So it becomes an easier problem to route across the network. Now, of course, the downside to having these hubs is that they are central points of failure, possible failure. So if one of these hubs goes down, it takes a bunch of this payment infrastructure with it. And, no money's lost, but it's still potentially not good. And another issue is that they become potential targets, right? So they can be targeted with KYC and money transmitter sort of laws and stuff, and can potentially be shut down that way, which is actually happening now. So this is a real kind of problem here. Before we get to the main issue with Lightning, I'll just mention two more relatively minor issues. The first is around liveness. And what that means is that you need to essentially watch your channel to make sure your partner doesn't cheat you. Because the way these channels work is that you and your partner exchange little messages that you both sign saying, okay, you owe me 0.001 Bitcoin. Then we're going to update that to you owe me 0.002. So that represents two like micropayments of 0.001 each, right? And we continue doing that, and we're essentially updating our like ledger between each other over time. And what your partner can do is they can try to close the channel using one of those old states of the record of the ledger. And if you're watching, you can prevent that because you have the up-to-date ledger that's signed, right? But if you're not paying attention, they can potentially close the channel at a time where they owed you less money, basically, right? And they can basically rug you. So you have to keep an eye on the channel. You also have to be online to receive payment. So that's just a little, it's kind of bad UX. Like a payment can fail because the recipient's node wasn't online. You can't just send the money and have it just work, right? And another issue is that you have to keep a backed up record of these signed transactions, right? Because if you have this activity happening and you lose all of those signed messages, well, you better hope that your partner has a copy of them or is willing to give you the copy of them, because they might have sent you a bunch of money, they might owe you a bunch of money, but if you lose the record, you're out of luck, right? You're gonna have to hope that they have a record and that they're honest and so on, right? So these are little issues that have to be accounted for. And if you want to read more about that stuff, I would suggest reading this post. I'll link it below. It goes into a lot of detail. And so next we'll talk about the major issue with Lightning. Okay, so all of these issues that I've mentioned so far are perhaps surmountable, but the one that is not surmountable is the fact that, as I mentioned, all channel management, all opening and closing of these channels has to be done through the L1, right? You have to actually interact with the Bitcoin L1. You have to do a transaction there to open or close a channel. So Lightning is always going to be fundamentally limited by the throughput of the L1, right? And you might say, well, that's not a huge deal. Bitcoin transaction fees right now are like $5. So I can open a channel, do my transacting. Then when I need to add capacity or close the channel for any reason, I just spend another $5 equivalent of Bitcoin. That's fine. It's okay to do that a few times a year. But every hyper Bitcoinization scenario projects that the L1 fees will be hundreds of dollars or even thousands of dollars on the L1, right? So if managing your L2 Lightning system, your channel, requires 2 of those transactions a year, well, that completely eliminates the possibility of this being a scaling solution for people who aren't moving a lot of money, right? Like if it's $1,000, or say $1,000 to open a channel and $1,000 to close it, and you want to do that like even just once per year, that's $2,000 per year just to manage this L2 stuff. And so it doesn't make sense unless the amount that you're moving onto the L2 is at least a couple $100,000, right? Because if you're paying $2,000 and you're moving, $200,000, that's 1% fee. Like that's a lot. You're certainly not going to move 5 grand onto the L2 if the fees are 2 grand, right? It just doesn't make sense at all. And to put some actual numbers and math to this, if you suppose that every person in the world were using Bitcoin and they were using the Lightning Network, that would be, 8 billion people. Let's say they do 2 transactions per year to open a channel and close it. And that's their only interaction with the Bitcoin L1. Well, that's 16 billion transactions on the L1 per year. But Bitcoin itself only does about 157 million transactions per year. So it just actually doesn't have the capacity to handle that. You would need blocks that are 100 times bigger, right? And that's assuming that all of the L1 was used only for managing Lightning, right? If it's more like 50% for managing Lightning and 50% for actual L1 transactions, then you're going to need 200 times bigger blocks. And this, by the way, is actually mentioned in the Lightning Network paper, the white paper, where they have slightly different calculations, but they conclude that they would need 133 megabyte blocks to actually like onboard the whole world to Lightning. And I'll also explain now why like this isn't even possible in principle, because you can't actually even onboard the world to the Bitcoin L1 itself, right? To get to the L2, for this kind of L2, for a state channel L2, you have to be on the L1 first, then you can kind of migrate to the L2. You can move some of your money there and go from there. But you actually have to get onto the L1 first. And even that isn't really possible with the amount of throughput that we have on the L1. So the Bitcoin L1 does not have the capacity for the management of its L2, not on a global scale, right? If the system were being used by 10 times more people or the whole world, the throughput of the L1 is just insufficient to manage the L2. But the throughput of the L1 is also insufficient to even just onboard the world to that system. Even if they're not going to do any transactions, even if Bitcoin is going to just be digital gold that people basically never spend, they just acquire it and then sit on it for a long time, even that doesn't work. And the calculation is basically the same. Right now there's like 100 million people who own Bitcoin. The world population is 8 or 9 billion. So we have to onboard, let's say 7.9, right? And Bitcoin does 5 transactions per second, 157 million per year. So just given that, it would take 50 years to onboard the world if 100% of block space is used just onboarding people, right? If no other transactions are happening, we're just going to send sats to new, keys, right? People, then it would take 50 years. And more realistically, if 50% of the block space was used in like sending Bitcoin to new accounts, it would take 100 years. So like that's just not practical. The L1 just doesn't have the capacity to onboard a large number of people. And you might wonder, okay, is this possible with any crypto system? With Ethereum, the L1 is also like doesn't run super fast. So is there the same problem there? But the difference is the L2s on Ethereum are quite different. You don't have to onboard through the L1, right? You can join Base or Optimism or Arbitrum or any L2 without ever touching Ethereum L1. You can just, join there. And you can actually have the private keys to that account. You actually do own the ETH or whatever asset you buy on Base or on Optimism, even if you've never used Ethereum L1 ever. And, a solution to a lot of these issues that has come up, not just the throughput issue, the cost of opening and closing channels, but also the UX issues that I've mentioned. The solution that has arisen to these is custodial services, right? It's you own an IOU to some Bitcoin in the Lightning Network, and that can sidestep these problems. You can actually just join the network that way. So if you're a brand new Bitcoin user, you could never touch the L1 and just basically buy an IOU on the Lightning Network, and then you can transact no problem. It's all good. But of course, you have an IOU, right? This completely defeats the whole purpose of the system. Is you're not supposed to be, we're supposed to actually have control of these assets. So this is just like a laughable solution, in my opinion. And these issues that I've raised are being discussed in the Bitcoin community too. Here's a tweet about how, Lightning was designed under the assumption that the main chain, the L1, would be cheap-ish, right? And if that's not the case, the whole approach kind of breaks down. And, the fees are not going to get cheaper. They're only going to get more expensive. And, imagine what the fees would be at $1 million per Bitcoin. The L2 isn't going to really work because managing it will cost a fortune and virtually everyone gets priced out. And here's a point about the difficulty of onboarding people just to the L1, even for like the basic digital gold use case, is that given the throughput, without major changes, there's no way that even 1% of 1% of the planet will be able to afford to actually hold their own keys, right? It just isn't possible, right? So the solution, or what the system is kind of evolving toward, and I think this trajectory will hopefully be altered, but what it's evolving toward now is something like this, which is essentially a world where 99.95% of people don't own real Bitcoin in any capacity. And instead, what they own, what they own and control, is IOUs issued by banks, which is the system that we have now. So I'm attempting to depict this potential future with this diagram here. And what I've got going on here is I have Bitcoin, the L1 in the center, and then surrounding it, I have these things. These are meant to be whales, financial institutions, basically any entity which can afford to interact with the L1, right? So they have these little dotted lines connecting them to Bitcoin, to the L1. These entities are also able to afford to interact with and manage their L2, like manage their Lightning channels. So they have these blue channels open between each other. So they can transact between each other pretty quickly, pretty cheaply, but they're still bottlenecked by the L1, right? They had to onboard to the L1 and they have to manage their channels through the L1. So it's something that is only really available to whales and large institutions and whatnot, right? Then we have all of the regular users. So the 99.95% of the world, they can't afford to interact with the actual L1 or the L2. They have to use IOUs. Basically, they connect to one of these financial institutions, which itself is connected to the real system. But all of the users interact with that financial institution. They don't have any real Bitcoin. They don't hold any keys. They have an IOU, right? All of these guys have IOUs. Now, the obvious problem that I mentioned already with this is that if you do this, I mean, it clearly defeats the whole purpose of this entire endeavor, right? Like, if this is what we evolve toward, then we've accomplished nothing. You can pretty much just, like, I don't know, like, there's no, what's the point? But more concretely, if we did have a system like this, there's literally nothing you can do to prevent fractional reserve from occurring, right? If you have IOUs, you might say like, well, we could check that the Bitcoin blockchain is still, honoring the hard cap, which I'm sure it would. And that's fine, but you can't know that this guy hasn't issued, like, let's say we know that this institution holds 1,000 Bitcoin. Well, we can't actually know how many IOUs, how many Bitcoin IOUs it's issued. It could have issued 5,000. We would have to audit its books, right? Because those are its private records. We would have to audit it. So we're back to the same system we have now, which is where we have to like manually audit financial institutions and check that they're complying with the expectations and regulations and whatever. And clearly that doesn't work very well. So this approach, this the speed of the L1 and then the constraints and the fact that the L2 is bottlenecked by the L1 evolves, I think, inevitably to fractional reserve, breaking of the hard cap, basically a fiat system that we're trying to escape from in the first place. Oh, and this is also something that is being discussed in the Bitcoin community as well. Here's John Carvalho saying that banking is not a form of scaling Bitcoin. It's a form of scaling Bitcoin liabilities, otherwise known as banking. And I agree with that. So the last thing that I'll mention here is Liquid. And Liquid is just not a scaling solution. Like, it is a sidechain. Liquid is a sidechain run by 15 signers. It's an 11 of 15 multisig. So, I mean, if you want to use it, that's fine. But this is not real. This is IOUs, right? You don't actually control the Bitcoin that you put onto this network. It lives in a multisig, and then you can do stuff on this network, but you are trusting these 15 signers. It's an 11 of 15 sidechain, and you know, it's not even, it's a proof of authority chain. It's not even a proof of stake. It's not even like an open proof of stake system, right? Which I know most Bitcoiners don't like proof of stake. Proof of authority is way below proof of stake. It's an 11 of 15 multisig. So yeah, this should not even be considered as a real scaling approach. And this information is coming directly from the Liquid website. You can see here the Liquid blog, multi-signature wallet that requires 11 of 15 functionaries to sign. So not a good solution. Now, on a more positive note, I do think there are actual solutions to scale Bitcoin. I just watched the Bankless episode with Eric Wall, and he laid out the entire landscape and presented, I think, an actual path for real L2s to be developed on Bitcoin using ZK proofs and stuff like that. So I think there is a way to scale Bitcoin, but it's going to require probably a hard fork, probably opcat or something like that. But I think this is going to be crucial, right? Because like I said in the beginning, given the current scaling trajectory, assuming no hard forks are made and the L1 just doesn't change, I don't think it's possible. I don't see any way that you can scale the current system to anything like mass adoption, even for the basic digital gold situation where, you know, 99% of people buy it and never touch it again. They don't move it, they don't use it as cash, nothing like that. And, you know, so I think something has to change. The current trajectory is just, it leads to this situation. It leads to money printing, basically. And obviously that's not useful. And obviously, like, this just won't even happen. Like, if the trajectory is that we simply move toward this, then people are going to recognize that and they're just not going to adopt the system. Like, this future, I don't think ever actually manifests, right? If this is the trajectory we can see ahead of us, we're just going to say, well, why bother? We already have a system like that. So there's no, why would people join the system if this is the end state? Okay, thanks for watching. If I got anything factually wrong in this video, please let me know. I'll edit the description or something. But I did a lot of research and I think everything is accurate. I'll also say that my goal here is not to just criticize Bitcoin because I like Ethereum better or something. The goal for me is that I want to see problems solved. I want to see these systems solve the problems that they can and must solve. So in doing that, in building, engineering these systems, we have to attack them. You have to try to rip their face off. And if they're solid, you won't be able to find many problems, right? So you can only make something better by criticizing it as long as you attack it and then we improve it and we continue to update and, you know, improve the system, then we can actually build the solutions that we're trying to build. So anyway, that's the hope. And yeah, so next videos will be on eigenlayer And then I have some more layer 2 stuff and a bunch of other videos on the way. So anyway, thanks for watching, and see you next time. Bye.